We're going to do some conversions. And we'll be using molar mass and Avogadro's number as conversion factors. So to use this or to do these conversions, we're going to use dimensional analysis. And we've done that before. So remember, if you do dimensional analysis, you're going to have a system kind of boxes, railroad tracks, whatever you like to call them. Your given would be put in here, given to you in the problem. And it's also going to determine your Sig Figs, because we're going to have to go back to Sig Figs. We're still not putting anything in the box below. And then in the very last box at the top, this should be your unknown. So what you're trying to figure out. And then remember, when we get all of that done, we multiply, cross, and then divide. It's on bottom. A lot of times there'll be just ones on the bottom and you won't have to worry about that. But sometimes you're going to have other things on there. So these are different ways that we can talk about a mole. And as far as what it contains, if you notice, all of these are 1 mole, but they're different numbers because they're different units or they're measuring different things. So Avogadro's number tells us how many atoms, molecules, or formula units you have. These are all different types of particles. Talked about earlier, it's atoms if it's an element, molecules if it's a covalent compound, and formula units if it's a ionic compound. So if you see any of those particles in your word problem, that's going to be a hint that you're going to have to use Avogadro's number. Next one is molar mass. So this one is for aluminum, 26.98 grams per mole is how we've been just writing that. If we think about it as a conversion factor, it's 26.98 grams per 1 mole. 1 is always going to go with the mole, and the number, whatever you calculate or get off the periodic table, is always going to go with the grams. And then the last one we talked about in that kind of special unit, AMU, atomic mass units. If we are using that measurement, we can figure out the mass of 1 atom in AMUs. And that one we really don't use too much. So we're going to be using Avogadro's number, and we're going to be using molar mass a lot. So the mole has been defined as 6.022 times 10 to the 23rd atoms or molecules, whatever kind of particle based off of what you have, or the molar mass of that substance expressed in grams. That's what we've been doing, the grams per 1 mole. It can also be defined It can also be described as Avogadro's number if we're talking about molecules of a compound. If we talk about a molecule, and I usually just put MC, the word molecule means that it has a covalent bond in it. And that happens between 2 nonmetals. Metal plus non-metal. So diatomic molecules, they're molecules because it's 2 of the same atoms bound together. And I'm going to write what they are, and I am putting a 2 behind them because that's how they exist when they're all by themselves. So bromine, iodide, nitrogen, chlorine, hydrogen, oxygen, and fluorine. This is something that you need to memorize as we use it the whole year. So these particular elements are not stable as just one atom. So on these, when they are by themselves, they exist as two atoms bound together. That's only when they're all by themselves. So if I thought of making water, that's hydrogen plus oxygen gives me H2O. Hydrogen and oxygen are not stable as just a single element. So this would not be the correct reaction. I'd have to have diatomic hydrogen plus diatomic oxygen come together to give us water. They have to have that 2 with them, those 7 elements, when they're all by themselves. And then we have to do a little balancing it with our coefficients. So those you need to memorize, because you'll see in a minute, we'll do an example with one of those. And if you like a mnemonic, Brinkelhoff might help you memorize that. Just thinking of, that would be your Brinkel, and that would be your Hoff right there. Brinkelhoff. So let's look at some of the problems that we are going to be doing. You're going to have to go through a few pages. Like molar mass. Y'all don't forget, this is what we're quizzing over tomorrow, molar mass, okay? Not what we're doing today. I think it's right after the molar mass. It has the mole map at the top. I'm going to teach you this using dimensional analysis. This is called a mole map, and some students end up liking this. Don't worry about down here about the ideal gas law. That's a later unit. So if you look here, this has an arrow pointing this way, and this is a multiplication. The arrow's going this way with division, and same thing over here. What am I doing? The way that you look at this, let's say that I was given my mass and being asked to convert it to moles. So I would follow this. This is where I would start because that's my given. This is where I want to get to. And if you look, that tells me I'm going to have to do a division problem. So I would take my mass in grams, and then I would have to divide it by how many moles I had. Or I would have to, have to divide it by my molar mass to get how many moles I had. So that's how that one works. If I had my number of particles, so let's say I knew how many atoms I had, and I wanted to get that into moles, and I'm going to follow this arrow. It tells me to take my number of particles and divide it by Avogadro's number, and that would get me to moles. So you can decide later on if you like that or like dimensional analysis. I like dimensional analysis, but you'll have to decide kind of which one you're going to want to use. Conversion factors that we're going to be looking at and using. We're going to be using molar mass. Remember, that's always grams per 1 mole. There's never anything but 1 mole on these 2 conversion factors. Eventually, we'll get to something called stoichiometry, and there will be, but not for a while. So however many grams per 1 mole, you will either had to figure that up if it was a compound or if it was just an element. It makes it pretty easy just to pull off the periodic table. We're also going to be using Avogadro's number. And your hint that you're going to need to use that is in the problem, there's going to be some kind of particle mentioned. whether it's atoms or formula units or any of those other ones, molecules. And when we use Avogadro's number, it's always 6.022 times 10 to the 23rd particle, whatever kind you're looking at, per 1 mole. So today we're going to do some that kind of have just one conversion factor in it. And then tomorrow we'll do the ones that are longer that have 2 conversion factors. So let's just get started with it. So on my first one, there's a little typo. This needs to say how many grams of sodium chloride, not just sodium. All right, so if I look at this one, it says how many grams of sodium chloride are in 5 moles of sodium chloride. So that's my given. Given is in moles. And my unknown, or what I want to get to, is grams. And grams or mass mean the same thing. So sometimes it'll say grams and later on it'll say mass. So that means the same thing. This is 2 boxes. So what I mean by here, that is I'm going to have 2 boxes like this. This is going to be my given. Nothing here. And then here is going to be my conversion factor. I'm going to use, whether it's molar mass or Avogadro's number. All right, so let's just start our little process. So I always start with what I'm given, which is 5 moles of sodium chloride. And I want to convert it to grams of sodium chloride. So that always needs to go at the last box, top closest to your equals. Because if you do it correctly, that'll be the last unit you have left. So at this point, you follow your units. If I'm moles of sodium chloride here, I have to be moles of sodium chloride down here because I need those units to cancel. So right now in this box, I need a conversion factor that is grams per mole. So what have we been doing the last day that would work there? Molar mass. Molar mass. Remember when we do molar mass, my units are grams per mole. Okay. So that's what we're looking for here. So I would have to figure out the molar mass of sodium chloride, a little side calculation. Or you probably could just do this in your calculator. So I have 1 sodium, 1 chloride. I'm going to multiply it. Maybe. Sodium, and I have 1 of that. So for sodium, what is my mass? 22.99. My chlorine, 35.45, I believe. The 8.44 grams per 1 mole. So that's my molar mass. So that's what's going to go in this conversion factor, these last set of boxes. Once again, the 1 stays with the moles, so it goes down here. The number, in this case, 58.44, goes with the grams. So now if I look at that, my moles would cancel out. I'm left with just grams, which is what I wanted. So now all we have to do is put it in your calculator. In this case, it would be 5 times 58.44 and then divided by 1. So that wouldn't change. We have to worry about Sig Figs. Remember the Sig Figs are going to come from your given. So how many Sig Figs do I have in 5.003? So that means my answer can only have 3 Sig Figs. 292, and my units are grams. Anybody have any questions on that one? Not yet? Not yet. All right. So let's look at the next one. It's just going to, no, this one's the same thing. I keep on thinking it's flipped. All right. It says how many grams of magnesium. So once again, that's my unknown. And it's just magnesium. So if I have a single element, that always makes it easier. And I have 0.250 moles. So once again, I'm going from moles to grams. My given is a moles. I want to get to grams. So 2 boxes. Start with my given, which is 0.250 moles of magnesium. And I want to get here in my last box to grams of magnesium. Follow my units. If I'm moles of magnesium here, I have to be moles of magnesium down. So it'll cancel. So what number am I going to use for magnesium? It's just a single element. Remember, you can get that straight off the periodic table. 24.31 grams per 1 mole. Since it's an element, I don't have to add up a bunch of stuff. So I'm going to use that. So where does my 1 go, on the top or on the bottom? Bottom. It always goes with the moles. Means my 24.31 goes up here. Once again, my moles cancel out. I'm just left with grams. So I just need to multiply across. How many Sig Figs on this one? 3 again, right? So what did we get for? Anybody got our answer yet? 0.08 grams. That's my only unit left. I had somebody last period, they put grams per mole. Remember, you're not going to have that at the end of a calculation because your moles canceled out. You're left with just grams. Does anybody have any questions on that one yet? Not yet? All righty, good deal. So now let's flip it and we're going to go the other way. We're going to be given grams and we're going to want to get 2 moles. And this is going to show you one where you have a diatomic and you have to remember it's a diatomic. All right, so here we're going, my given is in grams. So my given is in grams, and or it could say mass. And I want to go to my unknown, which is moles. My unknown. So just a flip of the one that we did. So it's still 2 boxes. Still are not putting anything down there. So I start with my given, which is 44 grams. And I have to remember that nitrogen is a diatomic. So when we talk about that nitrogen all by itself, it's not just 1 nitrogen atom, it has to be 2. And I want to get 2 moles of nitrogen. So I follow my units. If I'm grams here, I have to be grams down here, so it will cancel. So what molar mass am I using? Remember, it's diatomic. So instead of 14.01, what's it going to be? 28.02. 28, if you have 2 of them, then it's going to be 28.02 grams per 1 mole. So that's why it's so important about the diatomics, because if they're all by themselves, it's always going to be, they're existing as a molecule. So my 28.02 grams still goes with the gram part, and the 1 goes with the moles. So when you're using a conversion factor, then the 1 is always going with the mole part of it that we're doing right now. So what are we going to do here? Instead of multiplying, we are going to divide. And how many Sig Figs? 3 again. And what did we get on that one? 1.57. You can put mole, put mol. Can't put little. You'll notice one of these was did yours die? Yeah, if you have it, like I had somebody last period that had it was set like, I don't know, in scientific notation. So it kind of cuts off your number before you can really decide on Sig Figs. So if you notice here, if I was going from grams to moles, like I did here, then that is a division, or I'm dividing and my number is decreasing. Well, I just say all these different little things for something may help you out. Before those, we were given moles and we were going to grams. So instead of dividing on that one, we multiplied. And my number increased. All right, any questions yet or so far? Yes, sir. Yes, ma'am. I can't see what it is. Sorry. Okay, you're talking about here? That? Is that what you're asking me? Okay, right here, it just told me nitrogen gas. And if you flip back to that other page, I think the box right at the bottom where I told you the diatomics, that little square box here, you know. So that means that when it's nitrogen gas and it's all by itself, it'll never exist as just one nitrogen. It has to be two. So that's true for those 7 elements. It would be nice if instead of saying nitrogen gas, that it would say N2 gas, because then it would kind of remind you. But on those, when they're all by themselves, you have to remember they're going to exist as a molecule, which is 2 atoms together, because they're not stable. So that's why we had to double that. Because if you look, it's just 14.01, but we had to double it because there was 2 of them. All right, any other questions? All right, let's add Avogadro's too. Well, we're not adding it. Let's put Avogadro's in it, Avogadro's number. And then tomorrow, we'll put it all together. Have 3 boxes. All right, so now we're going to be using Avogadro's number. And the hint that you need to use Avogadro's number in the problem, the word problem, it talks about some kind of particle. So once again, that could be an atom. That could be a molecule. Formula unit, although that's pretty uncommon. But if you see any of those, that's telling you that you're going to have to use Avogadro's number. And you're not on these. We're not using molar mass on these. So we're either going from particle to Avogadro, to Avogadro's number, or we're reversing it. It's still 2 boxes. We're not going to do the 3 boxes until tomorrow. What do you think the 3 boxes are going to have? Oh, yeah, both. They end up having both conversion factors. That's why it makes it a little bit longer. All right, this says how many atoms are of lead or in 3 moles of lead. So there's atoms. That's my hint that I have to use Avogadro's number. That's one of the particles. So it's going to be 2 boxes. And I'm going to start with what I'm given, which was 3.80 moles of lead. And it wants to, I want to convert it to atoms of lead. All right. So I follow my units. If I'm moles of lead here, I have to be moles of lead down here. So now we're ready for Avogadro's number. So like we did on molar mass, 6.022 times 10 to the 23rd particles per 1 mole. So once again, if we're using a conversion factor, the 1 is always going to go with the mole. That's where we're at right now. So our 1 would go down here, and our 6.022 times 10 to the 23rd. Open up room there. 23rd atoms would go up here. So now you're ready to put it in your calculator. Don't forget, like if you're multiplying, you're going to end up with a really large number. So don't forget your E that tells you what your exponent should be. I would do, the exponent part. I think you got to use that. I have that little pointy thing. I'm sure that's not that right there. I didn't. Okay, so you did 6.0 times 10 to the 23 times 3.80. Had you already put that in? Yeah, so this shows you. So you would just put, so if it looks like that, you're going to put 2.29 times 10 to the 24th. That's what that E becomes your exponent on the 10. Is that what you meant? Okay. All right, what did we get for the answer? Oh, I just said it. To the 24, and my units would be atoms. That's it. And don't forget, if you're given a scientific notation, like for instance, on this answer, remember that part determines your Sig Figs, that coefficient part. So we had 3 Sig Figs, so my answer had to have 3 Sig Figs. Right now, as I'm assuming you can guess, we're going to flip it. So now we're going to be given atoms, and we want to go to moles. So still 2 boxes. Oh, here we multiplied. What do you think we're going to end up doing here? Dividing. Yes, just like the other 2, they just get flipped. So I'm going to start with my (8.24) times 10 to the 24 atoms. Once again, that's one of the particles. That's my hint that I need to use Avogadro's number. And I want to get it to moles of sodium. So now we're going to follow our units. If I'm atoms here, I have to be atoms down here. So I have atoms and moles. So where's my 1 going to go on this one? Top, bottom. Remember, the 1 always has to go with the mole. Just like in molar mass, wherever the particle is, that's where your 6.022 times 10 to the 23rd needs to go. Now, as far as I know, if you're dividing by this big number with an exponent, you have to put it in parentheses. Y'all may know differently, but oh, what should I get? Should I get a real large number, or should my number decrease from what it started with? It should decrease, all right? That's a huge number I'm dividing it by. And how many Sig Figs? 3. Started with 3, so we need a 3. What did we get? Someone like share their answer? What did we get? I got, what, did anybody get 13.7? So maybe you just put it in your calculator wrong, maybe? If you want to try, did you put this part in parentheses? That bottom part? Is what? Oh, but it's 8 times 10 to the 24th. So, and now this number doesn't have any exponent on it. So it definitely decreased. Yeah, because you have to remember this had that part. So that was a huge number. And then I divide it by not quite equal, but a little bit smaller number. So this is your correct answer. 13.7 moles. So just like we did on the other side, if you're doing particle to mole, your number should decrease. That's what we did here. And then if we reverse that, if we're doing mole to whatever particle, my number is going to increase. I'm multiplying by 1 and I'm dividing by the other, and by Avogadro's number. All right, any questions on that particular one? All right, I'm going to do the 3-step conversions tomorrow. So let's look at the practice. You'll have to roll a few pages. Oh, actually, not too far. On the first page. All right, so why don't y'all look at number 1 and give that a try. So first of all, let's talk about, if you don't need to, then you can go ahead and get started. What are we doing in this problem? Number 1, what are we starting with and what are we trying to get to? Perfect. And we're trying to get to, atoms. And that's my hint that we're going to have to use Avogadro's number. Ava, if you look at the next one down, see number 2, it talks about mass. So that would be good. So anyway, all we've done is 2 little boxes so far. But the fact that this one of the types of particles, that's your hint, you're going to have to use Avogadro's number. 3.44 moles. And I want to get that to atoms. Follow my units. If I moles here, I have to be moles down and diagonal. So I'm using Avogadro's number. Is the one going on the top or on the bottom? Bottom. It's always going to go with the mole part. And then up here, I have that 6.0 times 10 to the 23rd. How many Sig Figs is my answer going to have? 3. I'm going to get a really big number, so don't accidentally miss your exponent on there. And when you're practicing these at home, the answers are on, I think the second page, really small at the bottom. All right. Did anybody get 2.07? All right. Don't forget your exponent part, times 10 to the 24th. And my units would be atoms. Yes, 2.07, that looked like. All right, why don't you give number 2 a try? Are we using Avogadro's number in Avogadro? I'm just in number 2. No. Are we using it in number 3? Yes. So y'all look for those words, because that's probably the biggest thing that people get confused is when to use Avogadro's number. Remember, if it says mass, that's the same thing as asking for grams. So this one is a mole to gram problem. Cobalt is element number 27 when you start looking for it. So if you're having trouble getting started, because I know sometimes that's just like, I don't even know where to go, but at least get started and know that this is all we've done so far. It's only going to have 2 boxes. And then whatever you're given is always going to have to go up here. Nothing here. All right, so what is going to go in this last space right here? Mass or grams, right? Grams of cobalt. And mole goes on the bottom. All right, so really, if you've done that part, that's kind of the hard part. Now I just need to grab a number off the periodic table, which is what? If you look, it's 58.93 grams per 1 mole. This is just an element. So now I have to decide where to put it. My mole has to have a 1, and this number, 8.93. So at this point, what are you going to do? Multiply or divide? Multiply. How many Sig Figs? 2. Remember that 0 is just a placeholder. Oh, does it? It's supposed to just be 2. The answer key has 3, but it's supposed to be 2. Sorry about that. So what should my answer be? Just plain old 22. And my unit would be grams. Right, so we're going to do the longer ones tomorrow, and then we'll continue to work at this, and same thing on Friday. That finishes up our notes, so we're going to spend a little bit of time on this so you can ask questions. So like I said, please try your practice. You should be able to do everything on the front page. We've worked through those types of problems.